Okay, we are videoing this class because a couple people emailed that they're not here, they wanted to be videoed. Okay, we're going to do something different on this homework. We'll try something different. Instead of me checking every day, this is how I actually do it in my other classes as well. We are going to just hand it in on the day of the test. So all your homework will be handed in on the day of the test.
Ooh, I like that.
Now, I know what you guys, some of you are thinking already. So the test is not next week, Wednesday, but the week after that. Can you see? And there's going to be 4 assignments, 12.1, 12.3, 12.6, and the practice test. There's 4 assignments, so that's going to be 20 points. You're going to hand all of it in on the day of the test. But now, since you are handing it in on the day of the test, not like I'm just checking it now for attempt. Now I'm checking it for correctness.
No.
Yes.
No.
Yes, because I want to.
Wait, so for the answer,
No, you gotta have work. You
Why
gotta
are
just
you
look
pulling
in.
this one?
Okay, then I'm gonna assign all even problems then. Let me change it then. No, because Suga here wants to write one right answer.
Are we gonna go over it in
do
class?
that.
Huh?
We're gonna go over it in class.
Yeah.
Oh,
So
okay, never mind.
of course we're gonna go
Bro,
over it.
honestly, I don't even know what the answers are in the book.
So if we correct it,
I don't
You know
know.
what? That doesn't surprise me.
it's so good. Yeah, like if we correct
That doesn't surprise me.
So that's all my homework is legit.
Wait, what if we have it on our iPad?
Then email it to me.
Wait, if we correct it in class.
I believe you have my email. Yes. Question?
Okay, so if we correct it in class with pen, does that still count?
Yeah, it's just gotta be correct. Pencil or pen, or if you want to write with blood, you can do that too. Did you guys ever see writing in blood? Did I tell you about this?
It's so gross.
Because on the math team, I tell, because you take a pencil into the room, what happens if the lead of your pencil breaks? How do you write your answer? You gotta write it in blood. That's what they did.
So you pick your nose and so starts bleeding.
No, not your nose. No, so what they did is they had their mechanical pencil, and then they scraped their finger until the blood shows. That's what they did.
Wait, what are
That's
you
so messed
talking
up,
about right
that's
now? Is
messed
this
up.
real life?
Yeah, math team, because in math league, when you go into competition, you go into the room with a pencil. Your pencil breaks, you cannot leave your desk, you cannot say, oh, can I sharpen my pencil? You have to have, like, if you have a mechanical pencil, you have to have your own extra lead. So if you just have a regular pencil and the thing breaks or you're out of lead, then what do?
Why don't they let you sharpen?
You cannot, because you cannot leave your seat, because you can look at other people. Just think about it. Think about it. Let's say you're at Castle High School, and then you see an Iolani student over there. Wouldn't you want to walk past his desk and look at like this?
No.
What do you mean no?
I'm seeing that you guys have won for the past 26 years.
That's 23, but
But who's counting right?
yeah, who's counting? Okay, any questions on last night's homework? The other class had questions.
25.
25, is that better not be 2 equations, 2 variables? And it
No,
is.
25 was pretty hard actually.
Is it inconsistent?
You don't even know what you're talking about, Chan.
Yeah,
I
it's
do.
inconsistent. Okay, never mind.
What are you wrong, Chan?
No, I didn't check with the back of the book, so I was wondering if inconsistent was the correct answer. and it is.
41.
So can we do 41?
41 and 53. Okay, now we're talking.
Mr. Park.
Yes. Yeah. 41. X minus y equals 6. 2x minus 3z equals 16. 2y plus z. We'll have a quiz on this next week. I don't know when we're. Yeah, but we're only meeting once next week, yeah?
So we can't.
We'll have the quiz the following week then. On Monday then. Even though you guys don't like it on Monday. Samba! Okay, first step. You have to decide which variable you want to eliminate. But look, this one's easy because look, this one doesn't have an x, this one doesn't have a y, that one doesn't have a z. So just pick one variable to eliminate.
X.
Wrong. It doesn't matter. You want to do x then?
No, that's.
Like, were you here last time? I told them, like, if you don't know, I always just eliminate the z. That's what I do.
Let's do Z.
Okay, good choice. Okay, now, do you notice this first equation doesn't have a z already? Why don't we call this equation 1, 2, and 3 then? Okay, so somehow using equations 2 and 3, I have to get rid of the z's. Now look, right here. What do I have to do to eliminate the z? I need to multiply equation 3 by... Look, this is a negative 3z. If I want to cancel it out, I need a positive 3z. So what do I need to multiply by? 3. So if I multiply equation 3 by 3, what are you going to get? You're going to get 6y plus 3z is equal to 12. Now, here, you know what? Why don't I write it right next to it? Here, I'll write it again. 2x minus 3z equals 16. See, because when they're next to each other, it's really easy to see. So if I want to get rid of the z's, what do? You add the equation. So add 2x plus 6y. These cancel out. And what is 12 plus 16?
28.
28. There you go. Now you just have two equations, two variables. See, that's your goal. Your goal is to get it down from 3 equations, 3 variables to 2 equations, 2 variables, because everybody can do that, right? Now, here's equation 1. X minus y equals 6.
Let's just eliminate.
Now look at that. Now you have to eliminate another one. Now, if you want to eliminate x, I would multiply this equation by -2 and add, right? If I want to eliminate the y, I would multiply this equation by 6, right? So which one you want to do?
X.
Multiply by what?
-2.
-2 or 6?
-2.
Okay, -2. Multiply the second equation by -2, so you're going to get 2x plus 6y equal 28. That's the first equation. The second equation is -2x plus 2y equals -12.
Add.
So you add, so the x's cancel out. 6y plus 2y is 8y, and 28 plus -12 is
16.
16, and look how nice it comes out.
Right, go to.
Divide by 8, what do you got? Y equals
2.
2. Once you figure out y, go back to one of these here to figure out what x is. So here, I'm going to get rid of this. So which one looks easier? This one, doesn't it?
Yeah.
I mean, it doesn't matter, okay? So plug in 2 here, so you get x minus 2 equals 6. Add 2 to both sides.
X equals 8.
X equals 8.
Wait, so where is double elimination right now? Like eliminating twice, right?
Yeah, but we just call it the elimination. And then, once you know y and x, how do I figure out z? Go back to one of these 3 here. So, out of these 3 here, which one looks the best?
First one.
No, but we can't use the first one,
That's it,
because
sorry.
we're trying to figure out z. So, this one, yeah? So if I plug in 2 for y right there, what is 2 times 2?
4.
So you get 4 plus z equals 4. Subtract 4 from both sides, z equals 0. Therefore, these 3 things intersect at the point 8, 2, 0. Now we discussed this last time. What are these 3 things again? When you have 2 equations, 2 variables, you're finding where those 2 lines intersect, right? So if you have 3 equations, 3 variables, what are you finding? You're finding where these 3
planes.
Thank you. 3 planes intersect. You guys know what a plane is, right?
Yeah. Coordinate plane.
So if you have 3 planes, where do they intersect? Well, at that point, it's 3-dimensional. Now let me just ask you this. What if you had 4 equations, 4 variables?
Then it's
What are you finding? You're finding where those 4
Planes.
hyperplanes intersect.
That was 40.
Oh, that's 4-dimensional. And this came up in the other class. Now, do you guys understand what 4-dimensional is?
No, I do
It's
not.
like another reality, yeah.
Yeah, exactly. Did you guys watch Interstellar?
Yeah.
They talked about going to the 5th dimension.
Yeah.
Wait, what does that even
That
mean?
was-
Can you explain that real fast?
Okay, first of all, let's start with 1 dimension. Here's 1 dimension. Let's call that the x-axis. So if you have beings and they live in 1 dimension, they can only travel on a line.
Beans.
Beings.
I heard that too, yeah.
Beings.
I was a little bit.
Okay, no, because I didn't want to say people, because they're not people. They're beings. Living things.
Just emphasize the G. You're saying beams.
You did. You said
Okay, whatever.
Beams.
These things.
You said beams.
These living things then.
Yeah, there you go.
Okay, can you imagine that? They can only travel on this line. So here are the living things. They can only travel like that.
So just-
They cannot even cross one another. So if you have Peter here and John there, then Joe gotta stay in between them his whole life.
Wait, I thought you said no humans.
But they can still have names.
No,
They can still have names, can't they?
No.
Okay, that's 1-dimensional. Okay? Now, what is 2 dimensions? Well, what if you get an axis and make it perpendicular to this? We call it the y-axis. Now we have a plane. We call this the Cartesian plane. Now, what if you have living things in this plane? They have to be two-dimensional, so they would be things. Now, did you guys ever read the book Flatland?
Oh.
You ever? You know, 20 years ago for Eli, there was summer reading for geometry. Yeah.
There's
There
something
was
that's
some
messed
reading
up.
of geometry.
But the last 15 years, no. Anyway, so if you read the book teaches you how to think about higher dimensions, that's why. So they're women. Women are line segments.
Oh, that's messy.
Okay, but this is you gotta read the book.
What are
And then males are polygons, so like
I think this
triangles.
are not as cool as
Wait,
they
that's
are.
like better.
No, but well, this book was written in either the late 1800s or the early 1900s, so it was long ago. Anyway, the more sides you have, then the more noble you are. So like,
It's like a decagon would be like.
so that'll be like a kid, and then see this is like a,
But a male kid.
the judge maybe?
Sure.
Anyway, I'm just telling you what's in the book here. Now, can you imagine just living in the plane, that's your whole universe, just people moving around? See, in the book, women are dangerous because what if you're a man and what if the woman is coming straight at you? How do you even see the woman?
They're a dog.
Cannot.
Because think about it, if you live in a plane, okay, here. Yeah.
No, guys, this is my
All you
glowing
can see
stuff,
is
like,
that. That's all you see. So here's Ben,
gave us this
and
whole
here's
stuff.
Joel, and here's Carol.
Why Carol?
Because it's a woman. She's a line segment.
Oh, I see.
So
It's just
if
a
she's
dot.
sideways, see, if you look from here, then you'll see her like that. But if you look at her like that, then all you can see is this tiny point there. And then how can you tell if she's coming at you or going away from you? It's hard to tell. Anyway, if you read the book, they say there's a light source somewhere, and then it makes shadows, and then you can kind of tell if they're coming or going. But there's a rule, they call this flatland. Women have to emit sounds, so you know where they are, because they're really dangerous.
Bro, how many times did you read this book?
Great.
I read it
I
twice
kind of want to read
in my
it.
lifetime.
Okay.
But there's a movie about this, and we're gonna watch it next week during
No
extended.
way, no way. This is fun.
Yeah, and it's a cartoon, obviously.
I wanna watch Interstellar again.
Anyway, listen to this. This helps you think about higher dimensions. Okay, this is 2 dimensions now, right? Now, what is 3 dimensions? Well, that's the world we live in, right? So, what if I take an axis that's perpendicular to both this one and that one? That would be the z-axis, right? Which defines space. This is the world we live in, right? Okay, now, what about 4th dimension? Now, can you get...
Wait, Shrek, go over 3rd dimensions.
No, we live in it every day! We live in it every day!
Draw it on the board, draw it on the board.
How about just look at this classroom? It's 3-dimensional.
What about like 3D goggles and stuff?
3D goggles.
Yeah. Yeah, 3D glasses.
That makes it 2-dimensional. No, like.
I don't even know what that is. Okay.
The kind is blue and red.
Yeah.
Oh, you're watching the movie then?
Yeah.
Yeah, it seems 3-dimensional, the visual
But I
effects.
feel
Yeah, but how?
So it
Explain that.
it looks like it's right in front of your face and you try to
Yeah,
grab
but
it.
explain that mathematically.
I don't know.
So the light refracts a different way or something?
I don't know.
Let's look it up.
Okay, look, listen. Okay, so 3 dimensions. You get an axis perpendicular to the first 2. Now, can you think of another axis that's perpendicular to all 3 of these?
The M-axis.
That would define 4 dimensions.
Where is it?
Yeah, exactly.
Oh.
Where can I put another axis so that it's perpendicular to this one? No, because the z-axis goes the other direction too.
Yeah, see, we can't.
On top.
No, because if it's
We can't
diagonal,
think
it's not
of
going to
it
make a
because
90-degree
it's just not
angle.
possible.
It's got to make a 90-degree
Well,
angle
yeah,
with all 3 of these.
What about?
See, you can't think of it because you guys are only thinking 3-dimensionally, that's why.
I think 7 dimensions.
And that's why
Wait, what?
that thing will form the 4th dimension.
What about perpendicular to the leaf? She has a concussion.
Okay, just think about it. Okay, this is an exercise in thinking. Now, what if a 4-dimensional being wanted to visit us?
You couldn't.
How would we see them?
You couldn't see
Why?
that.
No, you can see them. No, we don't use goggles. So that would be too difficult to think of. So you know what we do? What if we think of, what if a 3-dimensional person went to visit these people here?
Then
We do it by analogy. Okay, so I'm a 3-dimensional person. Got all of these people, I don't want to say people, living things living in flatland here. How would I appear to them? Like, What if I'm talking here? Can you hear me?
Wait,
Can they hear me?
Yeah.
Yes.
Because they can only see what's in their plane now. They can't see anything. They can't look up like that, like we can. They can only see what's in this plane.
wait, so
Now,
if.
can they hear me?
Yeah, they can, because the woman give off sound.
Yeah, that's what we're trying to do.
Would we
That's what you
be
just said in the
3D
book.
and they be 2D, or
Yeah, we're
would
3D.
we
That's
be
we don't change and they
2D?
don't change. But how do we make ourselves appear to them? That's the question.
Stick your arm.
Exactly, that's what you do. Well, but the first question is,
I
can you
had-
hear
I had
me?
They
to stop.
can.
Yeah, because the sound waves go into their plane, right?
And also you said that the women have to give up sound, so they gotta hear us.
Okay, good. Yes, they can hear us. Okay, now if I'm standing right here, can they see me?
No.
So like Roy said, if I want them to see me, I have to put my body into their plane. So what if I put my hand in up to my wrist? Then what they see is, they see a cross section of it, where the plane intersects my wrist. So they're gonna see that then, right? That's what they see. What if I push my arm in further? Then, oh, I think I'm bigger because it's the forearm. And then what if I push it into my bicep and it's like really big, right? Right? You know what I'm talking about? Well, you noticed that. And then what if I pull my arm out and it kind of just disappears?
Ghost.
Yeah, put my arm back in, then all of a sudden they see a circle. Pull it back out, it's gone. Isn't that like kind of like magic to them? No, this is what I think. This is what I think. So think about it. What if a four-dimensional person wanted to come into our three-dimensional world? We
Oh my god!
we couldn't see them
Yeah.
unless they wanted us to see them, right?
That's like.
So they would have to put their body into our three-dimensional world, but we're only going to see a cross-section of
Sorry,
what they
so
really
you
are.
four-dimensional
But
things
their
would-
cross-section is three-dimensional though.
What the hell, Mr. Park?
I'm trying to teach you things.
No, it's
They
actually
go,
really
like,
cool.
in our
Like, if you
brains.
think
Okay, no, that's something else. This is just, you're just seeing
What does
things.
this mean?
Here's another thing that'll blow your mind. Here.
About that.
What if, okay, here's a man. Here's a man. He has like something wrong with his kidney. Okay? So he goes to the doctor. Yeah, this is an exercise for your mind here, okay?
In the 2D
He needs an
world?
yes, in 2 dimensions. He needs an operation. So here comes the doctor. 3, 4, 5, 6, 7, 8. Signs, whatever. Here comes the doctor. How is he gonna operate on the kidney? You gotta cut
Has to go
open the
through
person, right? You gotta cut him open, then you gotta go in and fix it, and then you gotta stitch him up, right? Okay, but now I'm 3-dimensional. I look over here. Hey, I can see all his organs. Look. Okay, all his organs. I can see it. I can see it. Oh, there's something wrong with it. Here, why don't I fix it? Okay, done. And you didn't have to open them up. So just imagine, okay, what if a four-dimensional person, they can see inside our body. Just like this, I can see inside their body.
He's cured us of cancer.
Mind blown over here.
Different. We have like they just have area. They don't have like
Exactly.
volume. So
But then 4-dimension, we only have volume. We don't have hyper volume like they do,
How do you know they have hyperbolic?
because we have volume.
so
And-
then
but
where's
they
the
do.
line?
There is no line, it keeps on going.
Wait, is there even such thing as a word?
It keeps on climbing higher and higher.
Oh,
So, does this remind you of
Our
something?
bodies.
Oh, I can hear something, I hear it, but I can't see it.
Like
Ghost.
schizophrenia.
That never happens to me, Mr. Park.
But then, now I can see them. Now I can't. Now I can see them. Now I can't, but I can hear them.
I'm gonna go crazy.
Exactly.
now.
Isn't that what ghosts are?
So,
That's what I think people think are ghosts. It's just 4-dimensional beings visiting our
are they
3-dimensional
just
world.
ghosts? And they're haunting
I
us.
saw a picture of Michael
It's
Jackson
purgatory.
at Janet Jackson's concert. He was like a ghost. They showed it in Japanese class last period. He was like a ghost at her concert. Someone took a picture of it.
Yo, Mr. Park, this
So it's
was
like a hologram.
this was the fourth
No,
dimension
they
looks
said
like.
there was no
It
hologram.
is
That's a hologram.
Photoshopped.
What is that?
No.
It's the fourth dimension.
That's not the 4th
I just looked it
dimension.
up.
But that's not the 4th
What if
dimension.
it was like?
It is, look at this, right?
Okay, can we move on to? I thought we were gonna finish early.
I can't even like process
Wait, can we
anything.
go over number 43?
Right, like like now you're just gonna.
Anyway, now that you,
Like,
now you
it's
go
always
and watch
always
Interstellar,
in
maybe
it.
now you can understand a little bit more about fifth dimension.
Spark, that was 15
Wait,
minutes.
so what was fifth?
Those
A
five
fifth
minutes.
dimension is one level above the fourth dimension.
Why do people think about these things?
Because they exist, that's why.
How do you
In fact, somebody told me, somebody did a proof or something that, I forget what it was. There's
Research it.
23rd dimension exists, everything up to the 23rd, I don't know, something like that, I don't know.
How do you
I-
even know that?
Oh, we're too simple.
Yeah, we're only at level 3.
Okay, anyway, today's lesson, are we ready for today's lesson?
We have a lesson today?
Wait, I thought we were doing 43.
What?
We're learning.
Oh, 43?
We kind of are.
Okay, let's do one more like, we still will finish 20 minutes early, don't worry. What are you guys worried about, little babies? Okay, 43 is a little more challenging because none of them are zero.
Oh my god.
Now, you guys better get good at this because we're having a quiz the Monday when we come back after Thanksgiving now.
I thought on the notebook pages only one.
3x plus 2y minus 2z is equal to negative 10. All right, first step. Decide which variable you want to eliminate, x, y, or z. Okay, z. Okay, well, let's call this equation 1, equation 2,
Why don't you just go
equation
y
2.
and multiply the second one by 2?
See? Oh, Sean is. See, he's looking. Yeah, eliminating y would make sense, but everybody here said z. It doesn't matter, that's why. You just pick one and go with it. But then z, this is 1z. Okay, now look at equation 1 and 2. What would I need to multiply this one by? So when I add it there, you can cancel out.
6.
No, negative 3. Right,
But that's
because
a negative
isn't
3z.
3z plus negative 3z 0?
Yeah, but then there's a negative 2z.
Okay. We're gonna multiply the second equation by negative 3. Go.
Negative 6x.
Negative 6x minus 3y minus 3z equal negative 12, right?
Wait, isn't it plus 3z? Wait. Wait.
You gotta multiply by negative 3.
No, but isn't that already a negative z?
No, that's plus z.
Oh, sorry.
I know.
What? Okay, here's the first equation. I thought you guys wanted to finish here. No, we want to prolong it. Okay, now look, line them up, and if you want the z's to cancel out, you add them, right? What is this plus this? Negative 5x. This plus this.
Negative 5.
Negative 5y. The z's cancel out equal
Negative.
negative 5. Ooh, it comes out nice. In fact, do you want to reduce that now or leave it? Can you see that you can divide everything by negative 5?
X minus y equals negative 5.
It's up to you, yes or no? Leave
Yes,
it or divide by
reduce it.
negative 5?
Reduce it.
Leave it.
No, reduce it.
Yeah, reduce it. If you make smaller numbers, you have less chance of making errors. Divide everything by negative 5. X plus y equal 1. Isn't that way easier to look at? Okay, now that was just equation 1 and 2. Now you have to involve equation 3. Now it doesn't matter if you combine it with 1 or 2, but you have to involve equation 3 now. So here's equation 3. If I want to, okay, so get rid of this. If I want to make this z disappear, what would I need to multiply this by? 2, right? Because then positive 2z and negative 2z will cancel out. So now I'm going to multiply the second equation by 2. Go. Do it.
4x.
4x plus 2y plus 2z equal 8. Here's the third equation. Negative 3x. Now you don't have to keep writing it like I am. If you want to skip steps, you can. Line them up and add. Go.
Negative x.
Add x plus 4y. The z's cancel out and 8 plus
Negative 2.
Gosh, how come we cannot add like whole numbers?
The negatives and positives
Oh.
look like these.
Okay, anyway, do you see what we just did? I reduced 3 equations and 3 variables to just 2 equations, 2 variables. That's what you want. Because we know how to do that. That's algebra 1. Okay, so let's line them up. X plus y equal 1. And look, if I want to get rid of the x's, what do I do? Add or subtract them? You subtract. So this minus this, 0. This minus this,
3y.
3y. This minus that,
Negative 3.
negative 3. Divide by 3, y equals negative 1. That's what you want. Now, once you get y is negative 1, you plug it back into one of these to figure out x. Which one looks easier? This one, yeah, this one looks easier. So if y is negative 1, Add 1 to both sides, what is x?
2.
X is 2. Okay, now that I got x and y, you go back to one of these up here to figure out z. Which one looks the easiest? The top one?
No.
Because
Yeah.
it doesn't matter, because they're all going to come out.
Wait, the second one.
The second one, because you don't like minus signs. That's sad. Okay, whatever, okay. If x is 2 and y is -1, what do we have? 4 minus 1 plus z equals 4. So 4's cancel out, therefore z equals, add 1 to both sides? Add 1 to both sides?
Wait, what's the question?
1.
Oh, sorry.
Do you wanna get some?
No, nothing works.
No, I'll tell you what works.
So you have to exhale and then.
No,
swallow.
this is what I heard.
Hold your breath.
Yeah, you hold your breath and hold your nose.
And then you drink really small gulps of water.
Really? I thought you just did.
No.
It works for
No,
me.
this is what you do.
Okay, okay.
Hold
No,
your
I want to hear
breath.
this.
No, I'm like the expert at
You have
getting
to
rid of
swallow.
Okay, I want to hear
Yeah,
it.
you swallow.
So
you
when
gotta
you
swallow.
drink water, you take really, really small gulps, but you hold your breath. Like you take as many as you possibly can. And
That
you
sounds
hold your
stupid.
What if you
breath.
don't?
No, it
Very
works.
good.
And then you burp like
Swallow
5
as fast as
times,
you
and
can.
then your hiccups
Blow
are
up
gone.
and swallow as fast as you can.
No, you hold your breath and you concentrate and you bring 2 fingers together.
That's freaking retarded.
No, like I'm
Hurry up, you're gonna go up, hurry up. Okay, so therefore,
It works.
these 3 planes intersect at the point 2, -1, 1. There.
Where did he go?
Okay, let's do today's lesson so we can finish
That
20
wasn't
minutes early.
today's lesson?
No, this is the homework.
Wait, which one was that?
That was, I erased the number.
43.
43.
Oh my gosh, I did that one. And I did it right.
See, this is not hard. You just practice a couple times. It's not hard.
So this is 12.2.
Okay, no, because we're skipping 12.2. Now it's 12.3. Okay, do you guys know what a matrix is?
Oh, yeah.
Yeah.
Yeah, because you have to know on the ACT and the new SAT, they have problems with matrices. What is a matrix? A matrix is a rectangular array of numbers like this. 1, 2, 5, 4, 3, 1. This is a matrix. Now, if I were to ask you, how many rows does this matrix have? What would you say? It has 2 rows. How many columns does it have? Look. It has 3 columns. So if somebody were to ask you, what are the dimensions of this matrix, you would say 2 by 3. You always give the number of rows first. Now, let's just do some simple matrix operations because these are going to be on the SAT. If this is matrix A, what is 2 times matrix A? How do you think you multiply a matrix by a number? You just multiply every element by that number. So 2, 4, 10, 8, 6, 2. That's how you multiply a matrix by a number. Just multiply every element by that number. Easy, right? Now what about adding matrices? If this is matrix A and matrix B is, so how about 6, 5, 4, 3, 2, 1? Let's make up numbers like this. How do I add 2 matrices together? Well, in order to add them, they have to have the same dimensions, and do they? Yeah, because this is 2 by 3 and this is also 2 by 3. So all you have to do is add the corresponding elements. So 1 plus 6, 7. 2 plus 5, 7. 5 plus 4, 9. See how easy this is? 4 plus 3, 7. 3 plus 2, 5. 1 plus 1, 2. That's how you add matrices.
Wait, how do you know the dimensions?
The number of rows, 1, 2. Rows go across, columns
Oh,
go
okay.
up and down. Just like the columns of a building, right? They go up and down. Now what about subtraction? What if you go B minus A? Well, addition and subtracting is the same thing. So you take the elements of B and you subtract the elements of A. So here, 6 minus 1, 5. 5 minus 2, 3. 4 minus 5, -1. 3 minus 4, -1. 2 minus 3, -1. 1 minus 1, 0. That's how you add and subtract matrices. Easy, right? Super easy. But on the SAT and ACT, if they give you a matrix problem, it's going to be really easy. Now, did any of you take SAT prep this past summer? Then wasn't there like matrix problems? Now, if you have a matrix, a square matrix, in other words, if this and this are the same number, we can compute something about it. Does this look familiar?
Nope.
From summer school? This is called the determinant of a matrix. So if you have a square matrix, in other words, 2 by 2 or 3 by 3 or 4 by 4, we can compute this thing called the determinant. Now, on the problem that we had in the summer, they actually told you how to do it. But if you took Algebra 2, then you already know how to do it. To compute a 2 by 2 determinant like this, it's super easy. All you have to do is go this times this minus that times that. So A times D minus B times C. So do you see the difference between a matrix? See how a matrix has brackets? But if you compute a determinant, it's just these straight bars like that.
That's not absolute value, yeah.
That's not absolute value. So the first 3 problems on tonight's homework, all you have to do is, like, they give you stuff like this. Compute this. All you have to do is go this times this, which is 14, minus that times that, 15, and you get -1. That's the first 3 problems of tonight's homework. You can do each one in 5 seconds. Easy. But why do we learn determinants? Just so teachers have jobs?
Yeah.
No! No!
Yes, it's gonna apply to.
Because there's an application for it. I'm going to show you right now. It's called Kramer's rule.
Oh, Cramer, what does that mean? The show.
Mr. Kramer.
Named after the mathematician Gabriel Kramer.
Just 10.
What? What?
Nothing.
Look, we can be almost finished. You just keep interrupting.
I'm not interrupting.
Yes, you are.
Go
Okay,
forward.
suppose you have 2 equations, 2 variables. Now, in this class, we're only going to use this for 2 equations, 2 variables. But when you get to pre-calculus, we use it for 3 equations, 3 variables, 4 equations, 4 variables, 20 equations, 20 variables. Okay, so here, let me see, what I do is, if I want to make the answer come out nice, I think of the answer first. Okay, so here we go. 2x plus 3y equals 12. 4x minus, give me a number,
6y
y, 1y,
equals 19.
no, 10. Like I told you last time, you can't just think of any number. You gotta make it so it comes out nice.
Yeah, but we have to challenge ourselves.
Okay, now, solve these equations using Kramer's rule. Okay, I'm gonna teach you Kramer's rule here, okay? Now, in real life though, if somebody gave you these 2 equations to solve, you wouldn't use Kramer's rule, you would just use Algebra 1, because it's faster. But we learn from Kramer's rule that if we have 10 equations, 10 variables, then we can use them. Okay, here we go. First step, you compute the determinant capital D, which is this, 2, 3, 4, -1. Now, where did I get these numbers from?
A, B, C, D.
Yeah, no. Where did these numbers come from?
Oh,
The coefficients. So when you're thinking about it, think of this as the x column. See, the x's. Think of this as the y column. See, those are the coefficients of the y's. So this is your original determinant now. We call this capital D. Now compute d sub x. Now what is d sub x? D sub x is we're going to take these 2 numbers and we're going to put them into the x column right here. 12 and 10. That's why we call it d sub x.
Wait. How do you get that number?
Right here, 12 and 10.
Oh.
Take the constants and just put it in the x column. Now, what do I put in the y column? Well, you keep it the same as the original. See, the original is the key one right here. So 3, -1.
Also, all you're doing is switching the constants for the x's, yeah.
Say that again.
And then d sub x.
D sub x means take these numbers here, put them in the x column. That's what it means. Okay. So what do you think d sub y means? I'm going to take these numbers
Put in the y.
and put them in the y column right here. And then what do I put here and here?
The original
Yeah,
x's.
you look at the original one here, 2 and 4. Okay, now all you have to do now is compute each one. This is so easy. What is this equal to? I just taught you. This times this minus this times this. So this times this is -2 minus this times this is 12. What does that come out to? -14.
-14.
What?
I
If
thought
we
it was-
cannot do whole, what happens if we do fractions in
I thought
there?
it was 2 minus 12.
Okay, compute the next one. This times this, -12, minus this times this, 30. Oh, it's getting scary for you here.
-42.
-42. How come that one you can do?
It's because it's like the same thing.
Okay, now compute this one. This times this, which is 20, minus that times that, 48. Okay, good. Now remember, when you compute a determinant, if you just remember, start at the upper left-hand corner, it's easy. It's this times this, minus that times that, easy. Okay, now, so, Mr. Park, how do I figure out where these two things intersect? Well, here's the beauty of Kramer's rule. They will intersect at the point d sub x over d sub y over d. That's the point of intersection.
Oh, damn.
So, these two lines will intersect at the point, here's d sub x, this divided by the original one. What is negative 42 divided by negative 14?
3.
3. See how it comes out nice? And what do you think what the y coordinate is going to be? D sub y divided by d. What is negative 28 divided by negative 14? 2. Bam! Now, like I said, if you were given this problem in real life, you're not going to use Kramer's rule. You just use algebra 1. But I just want to teach you Kramer's rule because it's going to be important later on.
Do we use Cramer rule for
Yeah, because it's going to say use Kramer's rule to solve this system. So tonight's homework, you just use Kramer's rule. So that means on the test, if you use algebra 1 to solve it, you're not going to get credit for it.
What? But you get the correct answer.
It doesn't matter because it's going to say use Kramer's rule to solve this system of equations. Isn't this easy? Now, I changed the homework, I made the homework easier. Because last year's homework, 2 years ago when I taught Algebra 2B, we had to do this. Because I just decided to teach it to them just for funsies.
It's fine. Don't worry about it.
What happens if you have 3 equations, 3 variables? Then you have to solve something like this.
It's fine.
But then you have like D and Z, right?
Yeah, but computing this is not easy. See, computing a 2 by 2 is easy. You just go that times that minus that times that. But when you have a 3 by 3, it's not, just believe me, it's not easy. So you guys don't know how lucky you are that we're not doing it this year. Unless you want to learn.
No, I'm good. Monday, Mr. Pop, Monday.
No, that's because, the last time I taught 2B, I said, we don't, because this is optional. This is what you need to, this is what's going to be on the final exam. This is optional. And you know what the class said? No, let's learn it, Mr. Park.
What scrubs?
Yeah, but guess what? They were in my AP calculus class last year. They all got 5s on the AP exam.
Oh.
Well, just letting you know.
Students like
Just letting you know.
5 years ago voted to have
Just letting you know.
after whatever.
Okay, we are done. Well, we finished 17 minutes early. That's something, I guess.